Hello. I guess what's that?
I guess my voice is audible clearly. Am I audible? Audience, students, teachers, and viewers.
From the audience. Good evening. Good evening, everyone. I guess my voice is very clear to the audience. I'm pretty sure. So let me please.
Yes, I'll proceed. I'll proceed further.
This is trying to start. Trying to start now. welcome to this class. So today session is last week. We are the process of completion of the landscape. So up to yesterday night classes we will speak about motion, motion class of motion, and related to series questions. So the viewers who are absent for last 5 days, yes, we can take live to make all the classes. And now today we are going to start gravitation. Let's start. Let's play. What is gravitation? Chat. Gravitation. Students can do that gravitation is related to on that was a downwards. Fall downwards. Right fall
Words. What's happening? Why do planets revolves around the sun? Why do planets revolves around the sun? Any idea? Is there anything related to gravitation? There is a doubt. Next. Why does moon revolves around the sun? Why does moon revolves around the sun? So, what is gravitational force? What is gravitational force? Why this and all is happening? Why moon does not collide with earth due to gravitational pull? Why moon does not collide with earth due to gravitational pull? Let's try to understand with its velocity. Take a stone, tie with the rope and you will it. You can see here there is left hand side, yes, which is a side view. From the top, it is a top view. Take a piece of thread, tie a small stone at one end, hold the other end of the thread and whirl it around. Note the motion of the stone. Release the thread. Again, note the direction of the motion of the stone. Why does stone keep moving in a circular path? What is direction of stone once it is released? So before the thread is released, the stone moves in a circular path with a certain speed and changes direction at every point. The change in the direction involves the change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called centripetal force. So what we understood in this activity, while we rotating the ball or the stone or whatever, so each and every point the direction is changing. It's a circular path. It's going with a certain speed. The change in the direction involves change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called centripetal force. Clear? In the absence of centripetal force, for example, you remove the thread, just you not apply the force. What happens? The stone flies off along a straight line. This straight line will be a tangent to the circular path. Clear? Now, why moon does not collide with earth due to gravitational pull? Why moon does not collide with earth due to gravitational pull? The motion of the moon around the earth is due to centripetal force. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. Not only does the earth attracts an apple and the moon, but all objects in the universe attracts each other. This force of attraction between the objects is called gravitational force. So now you understood that not only the earth attraction entire the universe, between any two objects there will be some forces. This is force of attraction between the objects, we can call it as gravitational force. Now there is a question, what is universal law of gravitation? What is universal law of gravitation? You can see there are the two masses. There are the two masses. Let's compare with m1 and m2. m1 m2 are the two masses. We have placed at the distance of r. Now gravitational force is directly proportional to mass m1 and m2, which means if mass increases, gravitational force will be increased. At the same time, if distance increases, gravitational force will be decreased. So F is inversely proportional to 1 by r square. Now, how to believe that mass increases, gravitational force will be increased? Let's say an example. We are standing on Earth. We are standing on Earth. At the same height, you can place 5 kilograms mass, 10 kilograms mass, 15 kilograms of mass, and 50 kilograms of mass. At a time you placed. Which falls down fast? More mass, more fast will fall down. Yes, more forces will be there. More force it will be applied on the earth. So once mass increases, gravitational force is increasing between the two masses. Now let's say with the different heights. One is 5 kg height over here. Let's say this is 2 meter height. At a 10 meter height, again you have placed 5 kilograms of mass. So which falls down faster? 5 kg mass, which is at 2 meters height. So once height decreases, which means distance decreases, gravitational force is increasing. In that case, F is inversely proportional to 1 by r square. Now both you can add it. Together you write it. So we can write F is directly proportional to m1 m2 by r square. Now the proportionality constant capital G. So F is equal to capital G m1 m2 by r square. So capital G is universal gravitational constant, which is 6.67 into 10 to the power of minus 11. Then most of the students are asking, sir, how to remember these units? We are forgetting about the units of gravitational constant capital G. Now we can define it. Now you can do the cross multiplication over here. Capital G m1 m2 is equal to fr square. So capital G is equal to fr square by m1 m2. So force units newtons, distance units meter square, per mass into mass, kilogram into kilogram, kg square. So the newtons finally we have achieved Newton meter square per kg square. So this is gravitational constant capital G. Hope students and few of the teachers, hope you understood that. Next. So just making the presentation with the same concept. F is equal to capital G m1 m2 by r square. Now capital G is a universal constant, 6.63 into 10 power of minus 11. Let's see. Let's see what you have understood. Which force is responsible for Earth's movement and the Sun in a circular motion? Anyone can say this answer? Which force is responsible for Earth's movement around the Sun in a circular motion? Option A, centrifugal force. Option B, centripetal force. Option C, gravitational force by the Earth. And option D, gravitational force by the Sun. Yes, audience, you can able to choose it. Anyone can choose it. It's like a fun game now. There is a question what it is. Yes, choose the answer. Gravitational force by the Earth. There is a student C learning. They opted. Any other? We'll see that. Now, before we have discussed, there is a rope as well as thread, the experiment. Similar way, the sun and earth, how which is revolving, you can able to understand. There is a something force. What kind of force it is? We can say centripetal force as well as gravitational force by the sun. The student C learning, once you can review it, there is a centripetal force. Of course, very good. You answered, you attempted. Appreciations. Next, there is a question. The mass of Earth is 6 into 10 power of 24 kg and that of the moon is 7.4 into 10 power 22 kilograms. If the distance between the Earth and the moon is 3.84 into 10 power of 5 kilometers, calculate the force exerted by Earth on the moon. G is equal to 6.7 into 10 power of minus 11 Newton meter square per kg square. So while reading this question, children will be confused, sir. Numericals and physics are very difficulty. We unable to understand. So we can able to solve it in a very simplest way, very smart way. While reading the question, always I'll instruct the students to write the given data. In the question, what they given the data. So the mass of Earth they have given. So mass of Earth, write it down, 6 into 10 power 24 kg. So what about the mass of moon? Again they have given mass of moon. 7.4 into 10 to the power of 22 kilograms. Next, what they given? The distance between the earth and the moon is, which means R value. How much they given? 3.84 into 10 power 5 kilometers. So the calculate the force exerted by the earth if capital G is equal to 6.7 into 10 to the power of minus 11 Newton meter square per kg square. So this is the given data. So once we write the given data in the examination, we no need to read the question again and again. Time will be saved. And we can go ahead what they are asking. That is required data. This and all given data what we written. What required data? Calculate the force F. Force F we need to calculate. Next, how to create a formula? Just now we have studied the gravitational force. F is directly proportional to m1 m2. F is inversely proportional to r square. F is directly proportional to m1 m2 by r square. And F is equal to capital G m1 m2 by r square. So how to check the formula now? Yes, we got the formula. F is equal to capital G m1 m2 by r square. Now, can't we solve this? Yes, exactly. Just substitute. So F is equal to capital G value 6.7 into 10 to the power of minus 11 into m1 m2 values. 6 into 10 power 24 m1 m2 in the sense of mass of earth, and m2 value mass of moon, 7.4 into 10 power 22 by r square, which means 3.84 into 10 power 5 whole square. Now again children will ask a question, sir, how these 10 powers has to be solved? What to do? Now all 10 powers you make it separate. You can continue f is equal to 6.7 into 6 into 7.4, actually what it is, into 10 power minus 11 into 10 power 24 into 10 power 22 by r square, which means 3.84 into 3.84 into 10 power of 5. Here you can see children, this is under newtons, this is under kilograms. So this kilometers we have to convert into meters. Kilometers we have to convert into meters. So 1 kilometer how many meters? Generally 1000, which means 10 cube. So we can multiply with into 10 cube. So finally 10 power 5 into 10 power 3, which is 10 power 8. So we can mention here 10 power 8. 3.84 into 10 power 8 whole square. So 3.84 into 3.84 into 10 power 8 whole square. This is the confusion. 10 power 8 whole square in the sense of generally children will think 8 square. It's not 8 square. 8 plus 8, 16. A power m power n, a power mn. So 10 power 16. Now we need to resolve this. 10 power 24 into 10 power 22, 10 power 46. 46 minus 11, 36. And above is 10 power 36, the down one is 10 power 16. Obviously 10 power 20. Yes, now all options are 20. Yes, so this is the way the 10 powers you can able to resolve it. Next, multiplication. 6.7 into 6 into 7.4 by 3.8 into 3.8. 3.84. So this we have to solve it. It comes 2.01 into 10 power 20 newtons. That is the right answer. Yes, this is the right answer. Yes. Yes, now it is correct. Now, how does the force of gravitation between two objects change when the distance between them is reduced to half? Yes, Aryan, very good evening. I am very so nice to see you. I guess you are at, yes. Nice to see you and happy to see you. The same classroom, you might be feel so easier. Yes. How does the force of gravitation between two objects change when the distance between them is reduced to half? Now, very simple concept over here. While giving that option A becomes 1/2, option B becomes 1/4, option C becomes 2 times, option D becomes 4 times. So how to choose it? Clearly mention the formula. Gravitational force F is equal to capital G m1 m2 by r square. This is the formula. But what they given in the question? how does the force of gravitation between two objects change when the distance between them is reduced to half? If r is equal to r by 2. So F is equal to capital G m1 m2 by r by 2 whole square. This don't forget, children. So now again a logic over here. Capital G m1 m2 by r square by 4. Always be careful. There are the two options looks similar. Don't confuse over here. Becomes 1/4 and becomes 4 times. Generally 4 is the answer now. Yes. But again r square by 4 we can write capital G m1 m2 by r square into 4. So 4 times of gravitational force. This is the right answer. Fine. We will see what is the right answer, what they have given. Yes, exactly. So whenever the given data, required data, formula, and what they are expecting from us. Yes. Now, yes, this trials has been done by Indian Air Force generally. What is free fall? Are anybody pushing them down? Are they freely falling down? So what is free fall? Free fall is a word which means freely fallen down. Yes, we know that. But freely fallen down when? There are the two situations. For example, the dry leaf which falls down. Dry leaf which falls down due to air pressure, let's say. Due to air pressure, leaf fallen down. It's not a free fall. Without any force, without any air pressure, if the leaf falls down, that is free fall. Clear? So we can say that without applying any force, if object freely falls, that is free fall. So what is acceleration of a free fall body? How does velocity change of a free falling object? This is the most important. Let's say whenever object falls towards the earth under gravitational force alone, we say the object are in free fall. Now my student, generally he'll throw the stones vertically upwards. While going upwards, at a certain height, it stops and again it falls down. Okay. Is there any change in the velocity of falling stone? If yes, what acceleration is responsible for a change in velocity? These two are the most important. While falling, there is no change in the direction of motion of the object, but due to Earth's attraction, there will be a change in magnitude of velocity. Velocity will be changed. This acceleration due to Earth's gravitational force. Therefore, this acceleration is called acceleration due to gravitational force of the Earth. Cause of Earth which is fallen down. By the Earth it is fallen down. So it is denoted by small g. The unit of small g is the same as that of acceleration. Yes. Now we can still consider there are the few equations over here. Hope you know that equations of motion we studied in the first chapter, motion chapter. One is V is equal to U plus AT. V is equal to U plus AT. In that, if an object freely falls down, once freely falls down, initial velocity U will be 0 and acceleration due to gravity will be positive g. In this case, apply these two over here. So V is equal to 0 plus g into t. So the free fall equation V is equal to gt. This is the equation. Next, S is equal to ut plus of at square. Again this equation how it is. Initial velocity u value will be 0, a value will be plus g. On that case, S is equal to 0 into t plus half into g into t square. So S is equal to of gt square. This is the next equation which is in free fall equations. The third equation, v square minus u square is equal to 2as. In that, again substitute initial velocity u value 0 and a value will be a, g value. So v square minus 0 square is equal to 2gs, v square is equal to 2gs, and v is equal to square root of 2gs. Hope these free fall equations are clear. Yes. Next. Yeah. This we are saying that different planets having that different gravitational forces. Absolutely. You can see that on the Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, individual planet having that individual gravitational force. So once if you place the rocket launch on each and every planet, it depends on the gravitational force on the planet. You can see if you want to launch a rocket on this Jupiter, very fast it goes comparably with other. And Saturn, yes. Uranus, Neptune, depends on the gravitational forces there of the rocket launching. Now, while in the free fall equations, we can understand what is the relation between gravitational force on a planet and universal law of gravitation. We will see in details. As you know that, as per Newton's third law or Newton's second law, F is equal to mass into acceleration. So mass into acceleration, acceleration due to gravity, F is equal to m into g. As per the gravitational force, F is equal to capital G, capital M, small m by r square. So both also again equal. So small m into g is equal to capital G, capital M, small m by r square. M will be cancelled. So finally, small g is equal to capital G m by r square. If you want to comparable to universal law of gravitational constant as well as the gravitational force on the earth or any other planet, so small g is equal to capital G m by r square. M is the mass of an object and r is the distance of an object from the planet. So there is a very important question. Calculate the value of small g when we put the values of capital G, M and R. So capital G value is 6.7 into 10 power of minus 11 Newton per meter square, and mass of earth 6 into 10 power of 24, and radius of earth 6.4 into 10 power of 6. So what is the gravitational force on the earth? If you know that any planet mass as well as the radius of the planet, yes, we can able to calculate while using the formula the gravitational force on the planet. So after substitution, so small g is equal to capital G value 6.7 into 10 power of minus 11 into capital M value means mass of earth 6 into 10 power 24 by radius of earth 6.4 into 10 power 6 whole square. So while doing this, we will get that g is equal to 9.8 meters per second square. Clear? I hope audience are understanding. Yes. Once you can see that what's happening in this vacuum chamber, they have given that one of a more mass, more weight, other one is less weight. If normally what happens, more weight will reach us down the earth first, less weight will reach us later. Okay, generally what we are observing in the nature. Now what we are doing, both are you place in a vacuum, there is no air. You can see that Both are placing at the same height, with the same speed, with the same time. Yes. So vacuum matters a lot. You can see that what's happening now. At the same time which falls down, even though it not depends on the weight or the mass. Whether all objects, hollow or solid, big or small, will fall from a height at the same rate. Now, take a sheet of paper and a stone, drop them simultaneously from the first floor of a building, observe whether both of them reach the ground simultaneously. We see that paper reaches the ground little later than the stone. This happens because of air resistance. The air offers resistance due to friction due to the motion of falling object. The resistance offered by air to appear is more than the resistance offered to the stone. Clear? Now, if we do the experiment in a glass jar from which air has been sucked out, the paper and the stone falls down at the same rate. We know that an object experiences acceleration during free fall. This acceleration experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. Now, there is an interesting question to the audience. A car falls off a ledge and drops to the ground 0.5 seconds. G value they are given 10 meters per second square. What is the speed of a striking to the ground? What is its average speed during 0.5 seconds? How high is the ledge from the ground? Option A 5 meters per second, 3.5 meters per second, 1.25 meters. Option B 5 meters per second, 2.5 meters per second, 1.25 meters. Option C 7 meters per second, 2 meters per second, 8.03 meters. Option D 2 meters per second, 22.5 meters per second, 10 meters. So here what you noticed, all are in the same units must be. So while in the question, a car falls off a ledge and drops ground at 0.5 second. So initial velocity how much? 0, because which falls from the ledge and drops the ground at 0.5 second. So initial velocity u value will be 0. How much time taken? T value 0.5 seconds. So G value obviously they have given 10 meters per second square. Now what is its speed on striking the ground? So this is the required data. What is the formula? V is equal to U plus AT. So V is equal to 0 plus A value how much? Acceleration due to gravity 10 into T value 0.5 seconds, which is 5 meters per second V value. Either A or B are the right options, but still there are the questions. What is its average speed during 0.5 second? What is its average speed during its 0.5 second? So time value 0.5 second, initial velocity 0, final velocity 5. So in the second case, initial velocity u is equal to 0, final velocity we got it 5 meters per second. So what is average speed? Average speed is equal to u plus v by 2, which means 0 plus 5 by 2, which is 2.5 meters per second. Obviously B option we can able to choose it, but still we can learn how high the ledge from the ground, which means height value. Again S is equal to ut plus of at square we can able to find out. So S value 0 into t plus time t, of course they given, but value will become 0, half into 10 into time value how much they given? 0.5 whole square, which means 0.25. Now once if you do that, so we will get approximately 1.25 meters is the right answer. So which one is the correct option? Which one is the correct option? B is the correct option. Yes, B is the correct option. Exactly. Oh, C learning chose B. Fantastic. Yes. Now, till now what we have studied? Definition of gravitational force. Yes. Universal law of gravitation. Universal gravitational constant capital GV is equal to 6.67 into 10 power of minus 11 Newton per meter square. Relation between capital G and small g. So what is free fall? So these are all the concepts what we have learned today. Any questions? In my description there is an email ID. If you have any doubts in the gravitation, yes, you can email me. At the same time, every day, Monday to Saturday, 10 to 11 p.m. Class 9th, then further stages, class 10 standard and 11th standard and 12th standard, the streamline will be happens. So Monday to Saturday, 10 to 11. And the main purpose of this, to reach to the rural India. So the children from the villages, they don't have any much opportunities to learn. So just I would like to help them for their studies and academics. You can see in my channel, if you not subscribe my channel and you get that notifications. At the same time, practicals in physics in future we are explaining. There are the science facts. What I noticed, why it is the science facts, which is recording classes will be there and science facts will be there. And find out some of it invited speakers in physics about the new concepts or science and technology. So invited speakers are there. So once you can see all the description, I guess hope you understood that what is gravitational force and what are all the concepts over here very clearly and how to solve the numericals. If any doubt is there, yes, you can reach me through email. Have a great day. Good night. Jai Hind.